No problem. Thank you. Yes, so as mentioned, my name's Steve Howard. I'm a advanced analytics technical specialist, reside in St. Louis, talking about Azure Databricks today. So I'm going to go through a short deck here, kind of roll through these and get into some demo. Of course, as far as Microsoft and Azure, we do a really, good job with hybrid scenarios, right? Being able to handle your entire data estate from, either on-premises to cloud. And really what we do on-premises, that all comes through the SQL Server environment. We have great benchmarks when it comes to performance, data warehousing, with SQL, 2017, especially being able to do R and Python directly inside of that environment. But then we also have our cloud services that really enable that, data and analytics at scale, with offerings from SQL Server to, data lake stores to the compute engines, the Apache Spark, or the Apache ecosystem, so to speak. So to kind of focus on that, if we were to draw kind of an all-up 10,000-foot architecture diagram instead of listing out the hundreds of Azure data services, this is just kind of a typical approach to big data in Azure. We're utilizing, Data Factory to orchestrate pipelines, move data between, on-premises environment to cloud environment. To utilize streaming data inputs from sources like Kafka or Event Hub, and utilizing compute engines, such as what you've had today, like HD Insight or Data Lake Analytics, and now with our Databricks offering to really be able to do a lot of that data processing on big data, and then to be able to serve that up into a serving layer like a Azure SQL Data Warehouse or Cosmos DB analysis services for in-memory models. So, a lot of this follows that typical kind of Lambda architecture of, your orchestration path. So what is Databricks exactly? You saw it on that last slide. Where does it fit in? Well, if you're brand new to kind of Databricks, you've never seen it before, it's really based on Apache Spark. Spark is coming over to this slide, right? If you're unfamiliar with Spark, it's a big data compute engine. It's really built around speed and ease of use. A lot of updates that have happened, with Spark 2.x, 2.0, and the data frames API has just really made Spark much more consumable. Spark's something that you looked at maybe 2 years ago, and just the barrier to entry was high. I know, coming from a SQL Server world, it was just a little bit hard to consume. It really has gotten a lot easier with the data frames API. It's really good at in-memory type of compute processing. As mentioned, it's 100 times faster than Hadoop. Now, Hadoop has made leaps and bounds as well with interactive query and LLAP, but in the end, generally, Spark is considered a faster engine. It is the largest open source, one of the largest open source data projects, and very extensible. So you're going to see, the ability to use multiple programming paradigms, Scala, Python, even R directly inside of the platform. If you're familiar with SQL and T-SQL, that's all usable as well. So then, if this is built on Spark, then what is Databricks exactly, and what is Azure Databricks? This is really, Databricks is built by the founders of Spark. So these are the folks that know Spark better than anybody else. I think they're the biggest group of folks that, contribute to the Spark project. But the idea here is just to make it really consumable. So the ability to spin up clusters at will to do your compute jobs, the ability for those clusters to auto scale up and down, to terminate after inactivity so that you're not burning resources in the environment. Being able to do role-based access inside the environment to ensure that people, only have access to what they should have access to. It's really great. And some of the add-ons for Microsoft, right, is, if you've done big data inside of Apache, HD Insight, for instance, just getting your security set up using Azure Active Directory domain services can be a little bit challenging. So this just straight out of the box uses Azure Active Directory. You can have your peers within your tenant be able to give them direct access to your workspace and go from there. So this is probably the summary slide. I like this slide. So, it really talks about what Databricks does well. It's about a collaborative workspace. It's a notebooks-based environment. I'll talk a little bit more about notebooks in a minute, but really can allow the data engineering process and the data science process all occurring in a single workspace or a single workspace. You can schedule jobs based off of notebooks that have been created. And then there's Spark optimization, such as, the active caching layer with Databricks IO. There's a serverless offering so that, whenever big jobs start running and start hogging all the resources, that's pretty typical as, data engineering jobs are running, that the serverless environment ensures that everyone still has access and everyone still, can get jobs ran, even with big data jobs running, taking up resources. And from a big data solutions, this is what we have in the cloud environment, kind of from IaaS infrastructure as a service. If somebody's using Cloudera on premises, you just want to pull that up and use it in Azure. You can do all that from our marketplace offerings. Azure HD Insight is really still a managed cluster. You can have some more options, so to speak, as far as how you tune HD Insight than maybe you do Databricks. And one other thing to keep in mind is, HD Insight is still what offers that entire Apache stack. So if you're a Hadoop environment, Kafka, if you use HBase, all those things are still what's provided through HD Insight. Databricks is really a Spark optimized platform as a service offering. So it's Spark only, but so I'd say if Spark is what you're using, then Databricks is the right place to start. But you may decide that there's other reasons you would want to use HD Insight for the environment. And then lastly, we do offer use SQL and Azure Data Lake Analytics. This is just a per job capability, so you can just spin up it spins up the resources as needed for any given job that gets sent in. It's not really a cluster, it's just really a per job service available to you. Everybody can just really read these bullet points really fast in about 20 seconds and memorize them. It'd be great. But this gives you that idea of some of the things we talked about, right? Is supporting the entire Apache stack is what HD Insight is good at. Databricks is an optimized environment for Spark, especially all based on notebooks. And then Azure ML, we have an ML Studio offering that's really good for kind of emerging data scientists, have this nice GUI-based environment that they can learn and use and grow with, as well as a machine learning workbench, which is a local tool that you can use to build Python code and then deploy to HD Insight Spark to run jobs at scale. All right, so some use cases. These are just kind of typical patterns and how you might include Databricks in that pattern. So if you just think of the modern data warehouse using maybe an Azure SQL DW, this would be an enterprise data warehouse scenario where it comes down to your users are primarily using the enterprise data warehouse. Spark, it can be that compute engine to really help you take data from multiple sources, do ETL workloads, translate to star schemas, etc., to help load that data warehouse. Spark can be used for that. And then more of the advanced analytics scenario, if you have a team that's doing more predictive analysis and machine learning, that's where you would allow them to be in this Databricks environment so that they can run experiments, they can do those predictive analysis, and then probably pump some level of that back into the data warehouse or move it directly to a serving layer like Cosmos DB. And then lastly, there's kind of that real-time analytics scenario where you're doing streaming sets from either Kafka or Event Hub, ingesting data, large amounts of data, bringing that into a Spark environment to kind of do the windowing functions or anything you're doing to reduce that down to something that can then be stored or served in real time. Okay, so really like to get into the product. This is my Azure Databricks workspace. It can be set up in the Azure portal. You just come into here and request a resource, say Databricks, and you will find Azure Databricks here. And through a few clicks, you can have this workspace set up in the region of choice in your resource group. So once that's done, there's a initialize workspace that takes you to this window. Now, what's really nice about Databricks is, for one, I mentioned this. Notice that up here I'm logged in as Steve Howe at Microsoft.com. So it is recognizing my Azure Active Directory credential. This is not logging in with admin and everybody sharing a password when we haven't went through the trouble to set up domain services. I am logging in as me, and then if I'm an administrator in the environment, I could choose to add additional users and invite them into the workspace. Then from the workspace, I have the ability to create clusters. So this is where I'm spinning up my Spark compute. Currently have one running right now, but if I were to create a cluster, I would come in and select hey, what Databricks and Spark version do I want to use, my Python version, and then notice I get many options from, memory optimized machines to storage optimized to compute optimized, depending on the type of workload that I'm setting up. Also, some value adds of Databricks is I can enable auto-scaling on my cluster so that maybe I could start with 2 nodes, but if jobs create a lot of back pressure on the cluster, it will just automatically scale up to have maybe 8 nodes, and then once those jobs are done and the back pressure is lifted, then it'll scale back down to the minimum workers. So this is nice to have this kind of elasticity in it. Then of course also auto-terminate. So after I leave for the day, if it's an interactive cluster and there's no activity on it, then it's something that the cluster can just automatically shut down, so that we're not burning those compute resources and paying for the compute resources. You can have multiple of these clusters kind of coming up, coming down as needed for different teams. But what's really nice is the entire workspace. I have, lots of notebooks that I've created. All of this is persisted for me. It's not that it all disappears when a cluster spins down. So all of the work that I've created and have is all saved inside of the workspace, and I could basically not be using, any compute resources for a week, so that I'm not burning that. Kind of those costs associated with those clusters, and I still have my workspace available to me. Okay, so we talked about, I mentioned a little bit about this is a notebooks environment. So I'm not sure if you're familiar with notebooks, but a lot of, Spark development's done in, Jupyter notebooks, maybe, and it's just a nice interactive environment to where I happen to have this overview notebook. I can do markdown in cells, right? So I can kind of take, HTML along with code and put it all into the same environment so that, it makes things really readable, right? So now, I have some information about the things that I would like to cover, but then I can also come in here and, run some code blocks throughout this, document the work that I'm doing, and be able to see, code plus HTML markdown all within one area. So here's just some of the slides that I was showing you. So this is, I could even do PowerPoint directly through the notebook if I wanted. But then as I go through and I want to, demo some of this, notice that, I have these multiple code cells that need to do some setup for me. These are some of the differences to just typical, Jupyter notebooks. I can come in and say, let's run all cells above. So let's get all these ran instead of having to wait for every individual one to go. And then one thing that Databricks offers is this idea of mounting file stores. So, for instance, I have this commented out here, but notice that this is a blob storage location in Azure, and I want to mount it to just mount NYC Taxi. This is the NYC Taxi data set with all the routes that over the last several years. And then I give it the configurations of, the location and then the blob storage key that was used. And now, anytime I run kind of a file system magic with a list here, I can see that this is accessing that blob storage directly. But now, anytime I want to access this from my environment, I can just do mount NYC Taxi, and it takes me directly there. So yeah, I can have multiple file stores, multiple blobs, Azure Data Lake Store as well. All of these things I can pull in and have mounted to my environment. And notice up here, this notebook is in Python. So if I'm using, the Python language, I'm going to use, a spark.read CSV. So this is going out and getting a month worth of taxi data from 2016, and it's going to pull it into a data frame that I'm creating called tempdf. It's going to infer the schema, make sure that it gives me, I'm keeping my headers. And then once I have this data frame, it's running across those clusters, I can see what's inside of it. And then the nice thing about notebooks, especially in Databricks, is let's say I want to create a temp view of that. Now, instead of using Python, I can just use the little SQL magic here and then run a count, right? And now I'm working inside of SQL. So if this is more natural for you to work in, then you can start doing a lot of data manipulation, with the language of choice, which might be Spark SQL. And so I'm just doing a count here, and this is going to return back about 10 million records. Or I can even come in and say, I want to use R now. I want to get a data frame back from this taxi. Right? So I can run this statement, and now I'm actually accessing the same data that I brought in from a blob CSV into a Python data frame is now being accessed from an R data frame. So I've used all these languages, and I could also use Scala as well inside of a single notebook. Here's some examples of being able to even hook up to JDBC resources. So like an Azure SQL data warehouse, I can hook up to that, create a data frame on top of this. And then, be able to explore that data frame with a filter statement. So if I just want to see the product keys greater than 50, this is another Databricks kind of enhancement here is I have this display command. So the display function allows me to just real quickly see, if I filtered this data frame, it gives me a nice HTML formatted data frame view of this information, or I can even do plots of the data that's included there directly within the cell. I can customize this, instead of a bar chart, if I want something else, right? Pie chart, for instance, I can do that as well and change that. So these are kind of the nice add-on features that this provides you. It does come with a full, kind of Hive metadata store, so I can create my tables. In this case, I was creating this directly off of the SQL data warehouse. So I created that, I don't know, many weeks ago. That Metastore is still available to me, so that I'm doing that count directly off of the warehouse when I do this, because I used a JDBC setting. And then all of this is then stored here. I can see it very easily. These are my databases. These are my tables inside of those databases. That's all available to me inside the UI. Any quick questions about Notebooks so far?
The example you gave about the SQL run against the data warehouse, is that the data warehouse? Is that the SQL data warehouse, or is it the data which is copied over to Bricks?
Nope. So because I'm using my JDBC connection, it's connecting over to my Azure SQL data warehouse right here.
Okay. Okay. See it. Another question is,
Yes.
So for example, in HD Inside, we have the option to use Azure Data Lake as the native data storage for that. So I think it is very good for performance because it is like HDFS.
Yep.
But in Databricks, is there such a plan to integrate with Azure Data Lake natively instead of like every time we have to access via the API like now?
As far as native, I mean, you can set up Data Lake as a mount, right? So as long as you have an application that has, you've registered an app that has access to your Data Lake
I understand
store.
that, but it's like a view into the, I mean, like every time you do something, you have to copy data from Data Lake and to Databricks and then do things with that, which is not good for performance. If there is such a native integration, so execution of the data transformation can happen near the data, you see. So mounting the data point.
I see what you're saying. Okay.
Yeah.
Well, yeah. I mean, we're not using the Data Lake Analytics compute engine, right? So it's just we are just using the Data Lake store, right? So all of the compute still is happening inside of the Spark platform.
No, so you see the point. For example, in HD Inside, right? So it has a native integration with, let's say, HDFS or Data Lake. So in execution, they can bring the execution closer to the storage, right? But with the current way of doing execution in Databricks, whenever you need data, you need to copy data from the source to Databricks and then perform the computation from here, right? So in a Hadoop environment, the job will be distributed together with the storage.
Okay. Well, yeah, I think. I mean, I'll let me take that offline because I'm still a little bit confused on what those options are you're presenting. Because when we connect to the Blob or the Data Lake store, we can connect to it directly. But yeah, I'd be happy to talk afterwards. Okay. Yep. Right. Thanks. Okay. So anyway, this is what's available. Kind of from a Notebooks perspective. Also, just as we only have a few minutes left, I just wanted to point out some capabilities as far as like being able to create jobs directly inside of Databricks. So if I come over here and choose maybe my batch jobs, I can create a workflow for multiple notebooks. So this allows me to run multiple notebooks in sequence from a notebook, and then I can take this notebook itself and schedule it as a job that runs, once an hour every 10 minutes, or I'm sorry, once an hour on 10. And then I can, set up parameters for that job. I can add library dependencies that I may have inside of my environment that I've already created, as well as run now and customize the cluster. So this job is going to create its own cluster to run, and then it'll shut that cluster down once the job is completed. So to be able to use notebooks to author the jobs and then be able to use this simple scheduler. It's pretty nice and intuitive. And then also I wanted to point out that libraries, for how we access and deal with libraries, you can grab libraries from either local jars, you can go out to PyPy or Maven, pull in the libraries that you need, and then if we just do, for instance, PyPy, which is already installed, but just to give you an idea, if I pull this in, I think I already grabbed one of those. Let's see here, sparkling. Go to Maven. You can go to PyPy, and really you can set this up to where any of these that you might want to pull in to your environment. Let's just go here to the ones I already have. This is where then you can automatically attach them to clusters when you run them, or specify specific clusters to attach them to. So this is nice because clusters will spin up and spin down, and you can make sure that the libraries that you want to include are available on them. All right, so and then one other quick thing on notebooks. One of the nice features in notebooks is it does keep revision history on those. So as you're changing things, you can notice that Sri and I both have been in this notebook. You can do interactive work. So if Sri's working in here as well, I can see what Sri is doing. From my side of the environment, I can see the revision history. We can also add comments as well. To different areas of the notebook if we want to. So that's all available also. Enhancements kind of from the notebook level that are available. I think we're at the end of our session. Any other quick questions I can answer?
Yeah, this is a great session, Steve. Thank you so much. And anyone has any questions, please come out of mute and you can directly ask a question from Steve. Well, if not, we will have this recording posted on our YouTube channel. So I pasted the link of YouTube channel in the chat window. Please feel free to join that channel to get the latest recordings and all the updates. So thank you so much, Steve, and you all have a great Friday.
Thank you, everyone. Thanks.
Yeah.